Have you ever faced a situation where your database operations just don't seem to work as expected? It can be quite perplexing, right? If you're dealing with drop table behavior in Postgres transactions, you're in the right place. Today, we're diving into this topic and clarifying your concerns. I completely understand how frustrating it can be when you're trying to manage your database and things don't go as planned. You're not alone in this. Many developers encounter similar issues, especially when working with transactions in Postgres. Let's look at the specific question at hand. One user recently asked about the behavior of drop table in Postgres transactions. They provided two approaches for replacing a table with new data from a CSV file. Sound familiar? Let's break this down together. So, what are the implications of these two approaches? The first approach locks the table during the drop command, which can block concurrent select queries. The second approach, however, allows select queries to run until after the copy and create index commands finish. Understanding these differences is crucial for effective database management. And stick around. At the end of this video, I'll share some additional insights that could help you optimize your database operations even further. First, let's discuss the behavior of the first transaction. The user is correct that when the drop table command is executed, it will lock the table. This means that any concurrent select queries will be blocked until the transaction is complete. Now, regarding the second transaction, the user is also correct. In this case, the drop table command is executed after the copy and create index commands. Therefore, select queries will not be blocked until those operations finish. Both transactions are indeed atomic. This means that if the user issues a rollback instead of a commit, the table will be restored to its original state, including all data and indexes. Finally, aside from the index name, there are functional differences between the two approaches. The first approach may lead to longer locks during the drop command, while the second approach allows for a smoother transition with less downtime. Fun fact, did you know that Postgres was originally developed at the University of California, Berkeley? It's come a long way since then, becoming one of the most powerful open-source databases available today. Now, let's look at the answers provided by other users. An alternative approach shared by another user highlights a caution regarding renaming tables in PostgreSQL. They warn that renaming may not always behave as expected, which could lead to issues in your ETL process. As for functional differences aside from the index name, there are nuances in performance and locking behavior that can impact your application. Always consider your specific use case when choosing an approach. And there you have it. Understanding drop table behavior in Postgres transactions can greatly enhance your database management skills. If you found this video helpful, please subscribe for more insights. And remember to keep experimenting with your database strategies.